Okay, my spoiled geometry children who need a video. We did rockets today, so obviously we don't have that instruction time. We're going to go over angle relationships. A lot of this is going to be review, but you are still responsible for it. So, how is an angle formed? An angle is formed by two rays with a common endpoint. So my picture's over here. My common endpoint is B, and my ray is BA and BC. The common endpoint is called the vertex. The rays are called the sides of an angle. If I want to name an angle using three letters, the middle letter must always, always, always represent that angle. So if I'm naming this angle, I would say angle ABC, and B is the vertex. That's that common endpoint that we talk about. If there's only one angle, it is absolutely okay to use the vertex as that angle. So I could also label it angle B. When I refer to the measurement, so how much is the value of this angle, I would say measurement of angle ABC is 60 degrees. And that's a big deal right there, that M. Okay, so that's when we're talking about the numbers of that angle. There are three types of angles. This is review from elementary school, but we have an acute angle. An acute, we know, is less than 90 degrees. We have an obtuse angle, which is greater than 90 degrees. And we have a right angle, which is equal to 90 degrees. So that's easy, simple. You've seen that before. Just a couple examples here. Name the vertex of the angle. The vertex is K. Remember, it's a point. And how do you name a point? You name it with uppercase letter. Name the sides of the angle. Remember, the sides are rays, so I have to label it as such. And notice I put KJ and the ray going out because my arrow, J, is the endpoint that is extending all the way. So I have KJ, and I also have KL, and the arrow goes to the right. Now, sometimes, people say, can I do LK and have the arrow go to the left? I mean, that's okay. It's just a little confusing. So usually we see that arrow pointing to the right. So I'm going to tell you go from the vertex and label that angle with the arrow going to the right. Okay, there are three ways to name this angle. Remember, we said if there's just one angle measurement with one vertex, I can label it by just the vertex, so angle K. Otherwise, I name it with 3 points. So it's going to be angle LKJ and angle JKL. And I can classify the angle as one of these three. It's greater than 90, so I know that it is obtuse. Okay? All right. Hopefully you have that written down. If not, you can pause it and slow me down. I know I talk too fast. All right. Of course, it doesn't work. Okay, there we go. All right, so example 2, name the vertex of angle 2. The vertex of angle 2, it's kind of interesting here because we've got more, we can say the vertex is T. The sides of angle 4 are going to be TW and TZ. I'm not going to go through all of these, but let's take a look at letter C. Write another name for angle 3. Here's angle 3. I cannot name it angle T because what is angle T? Angle T could be represented here. Angle T could be represented here. Angle T could be represented here. So when there's more than one vertex, you've got to label it with 3 letters. So another name for angle 3 could be angle UTZ. It could also be angle ZTU. Either one would be acceptable here. Okay, so that's what that looks like. And then, of course, when you classify the angles, we're talking about classifying by acute, obtuse, or right. All right, so that should be a little bit of a review. Nothing new should be popping out at you at this point. But let's talk about angle relationships. So the angle relationships, there are 5 big angle relationships that we're going to talk about. And vertical angles are angles that are directly across from each other. So when 2 lines intersect, they intersect at a point, and 4 angles are formed. Angle 1, 2, 3, and 4. Vertical angles are the angles that are exactly opposite of each other. So angle 2 is congruent to angle 4, because vertical angles are congruent. and angle 1 and angle 3 are vertical. And so once you have vertical angles, you know that there is that relationship of congruency. That means they have the same measurement. So vertical angles are congruent. And this is kind of what, if we had time in class, do you remember when you were little, you may have written your name out in paint horizontally, and then you would fold it over. And when you folded it over, you kind of got the reflection, and so it looks something, well, I don't think my C turned out right. It looks something like that when you flipped it over. So if you wrote out vertical, this V would be the same as this V, and the distance between them, that angle measurement would also be the same. So that's kind of another way, a visual you could use to represent vertical. But the big thing here is that vertical, did you see that? It was erasing and then all of a sudden it writes. I don't know why. All right, so that's vertical angle. Rewind me and pause me if you didn't get that example. Adjacent angles, adjacent means near or next to. So adjacent angles is that. If you had angles 1 and 2 in this case are adjacent angles. So if they share that vertex, remember I've got to label it differently. I'd have to label it with 3 letters, or I could just say angle 1 is adjacent to angle 2. Linear pair is exactly what it's saying. It's a pair of angles, 2, that form a line. So, angles 1, that's ugly. Angles 1 and 2, these are a linear pair, and if I said that they form a straight line, how many degrees are in a straight line? 180. So mathematically, I could say that the measurement of angle 1 plus the measurement of angle 2 is going to be equal to 180 degrees. Do you see that relationship? All right. Let's move on to complementary angles. Complementary and supplementary angles, I know you've seen this before. So complementary angles are 2 angles whose sum is 90 degrees. So if I know that that's a right angle, I know that their sum is 90 degrees, I could say that angle 1 and angle 2 are complementary. Now, these are complementary, and they're also adjacent because they share a common ray. They share this ray, but not all complementary angles are adjacent angles. I could say that this angle is 1, and this angle is 2, and what if this were 45 degrees and this were 45 degrees? These guys would still be complementary angles because they add up to 90 degrees. So not all complementary angles are adjacent. Supplementary angles are 2 angles whose sum is 180 degrees. So when you look back up here at that linear pair, these will always, linear pairs will always be supplementary angles because a line is 180 degrees, and 180 degrees means they're supplementary angles. So this always supplementary. But they don't always have to be supplementary. You could have an angle here that is 110 degrees and an angle here that is 70 degrees, and these would also be supplementary angles. Okay, so not always do they have to be adjacent, just like complementary do not always have to be adjacent. All right. Just randomly does that. Okay. So now, we're going to skip that one. Now when we look at these measurements, we can put some algebra behind them. First, on example number 1, what kind of angles are these? They're across from each other. They share a vertex. These are vertical angles. So if this angle is 112, x is 112 degrees. These guys have to add up to 90 degrees. So if this is 68 degrees, this is 22 degrees. And again, they have to add up to 180 degrees. Here you could do number 4 a couple different ways. You could look at it like x plus 43 is 180 degrees because that's supplementary. You could look at y and 43 are vertical angles, so y has to be 43 degrees. And then z and x are vertical, or you could do z and 43 are supplementary. Either way you want to do that. So those are kind of easier problems. If we jump down here, let's take a look. And we'll take a look at number 13. It's got our picture drawn out for us. So if DEG is 5x minus 4, and GEF is 7x minus 8, DEH is 9y plus 5. I want to find the values of x and y. So I'm going to go with what I know here. Remember, when we're solving an equation, you can only have one unknown unless we have systems of equations, which in this case we don't. So I'm going to start here. I know that these guys form a linear pair. So I'm going to say 5x minus 4 plus 7x minus 8 is all going to be equal to 180 degrees. And this is the algebra part. 12x minus 12 equals 180. 12x equals 192. X then equals 16. So x equals 16. And if x equals 16, I can go back and plug it in. So I can plug that in, and I'm going to do 9y plus 5 equals 104. So 7x minus 8, this is 104. This is 104. I cheated on that. I didn't do the math. I would have used my calculator and done 16 times 7 minus 8, but when you do that, it gives you 104. So now I'm going to say that these are vertical to each other. So 9y plus 5 equals 104. 9y equals 99, so y then equals 11. Okay, now be careful. If I asked you the value of angle DEH, 11 would not be correct, right? You would have to go back and plug in 11 and then give me the angle measurement of 104 degrees. So make sure you're looking at what your question is asking. Okay, that should take you through angle relationships. If you have any questions, come see me in tutoring, and then I'll answer these questions in class as well. Okay? Good job, guys.